In this video, I'm going to explain the working of the lattice modulator or diode ring modulator. So that is usually used in AM modulator, especially suppressed carrier, double sideband suppressed carrier. Before going to understand the ring modulator, in the ring modulator, the circuit has a center tap transformer. The transformers are usually looks like this. Usually these red wires are primary and these two are the secondary. Here also, these are the two wires and here three wires here. Okay. This is the common wire and green. These are the two. This is a center tap transformer. For example, in this rating is 12 volts, 12 volts with the current of 2 ampere. This is only a primary and secondary. Output voltage is 12 volts with a current rating of 2 ampere. Means physically the transformers are looks like this. And when come to this the voltages, this is the primary and these two are the secondary here. Okay. These two are the secondary, and polarity of the secondary is also very important here. Okay. And this is a symbol, primary and core. And when this positive cycle appears, with respect to the center tap, again this is a positive cycle, but lower side it is a reversed here. Okay, means it is a negative cycles. With respect to this center tap, this will be get reversed. But while coming to this is a as it is, whatever it is there, same cycle will appears. And also it is shown here. Okay, in this case also, when these are the plus and minus, and plus minus polarity is same, but here it is a reverse here. Okay, this will be a reverse, plus minus. So these are the primary here and the secondary physically looks like this, and polarity is like this. Now we'll come to the balanced model. A balanced modulator is a circuit that generates double sideband signal, suppressing the carrier and leaving only the sum of the difference frequency at the output. Means it has a upper sideband and lower sideband signals. Balanced modulator, it is used for amplitude modulators. And especially diode ring modulator is very familiar. Yeah, this is the circuit. Okay, it is used for balanced modulator. As usual, this is the center tap transformer. This is also center tap transformer, and this is the bridge circuit, and it has a 4 diodes, D1, D2, and D3, D4. Message signal or modulating signal is given to the primary of the transformer T1, and at the center of the secondary, T1, and at T2, primary of the T2, carrier is connected. And the same circuits can also be redrawn in this way. And this secondary is a modulated signal with the suppressed carrier. D1, just it is a redrawn circuit here. D1, yeah, we taken it out, and D4 because polarity is D4, and D2, yes, okay, D2 it is redrawn here. Means this cycle anode, yeah, this cycle anode. So in this way we can redraw the circuit. Again, modulating signal is connected to the primary of the transformer T1, and output is taken secondary of the transformer, that is the T2. This is the DSP signal, double sideband suppressed carrier signal. The primary of the T1 and secondary of the T2 carrier signal is connected here. This now we'll see the analysis. When message signal means this signal, and again these two circuit diagrams I am taken from a Lewis E. Frangel, and these two I have taken from a wikianalog.com. These two circuits are I have taken from a wikianalog.com. And when the message signal is absent, only we have a carrier. Okay. Means in this case, I'm not at all connecting anything. Means in this case, when only carrier signal is connected, means carrier is always very high frequency. This carrier is signal connected. What happens to this circuitry? Yeah, when carrier signal is positive, current will divide equally in the upper and lower part of the T1. Means when this is like current, you call it as I, it goes half of that I1 and half of that I2. When positive cycle comes like this, diode D1 conducts and positive D2 conducts. So that will come here when D1 conducts. So like this, it will come, okay, and circuit will closes. Similarly, half of the current I2, because this is reverse biased and D2 is a positive cycles. When positive, this is forward biased. Yes, okay, it will come. Look at this. The one current coming from diode D1 is direction is like this and D2 is opposite. Hence, when positive cycle comes, D1, D2 conducts and this current in this at this junction will be get cancelled and output is 0. Yeah. Similarly, when the carrier signal is negative, current will divide equally. Yeah, current will divide equally. Look at this. This is negative means in this way. Equally, in the upper and lower part of the transformer T1, diode D3 and D4 conducts. And when arrive at the transformer T2, both currents are in the opposite direction and the carrier current is, yeah. Now we'll see. When this is positive, yes, okay. When this negative cycle comes, current again divide equally. Yes, D4 is forward biased, will come like this and closes. And similarly, current will be divides and D3 is conducting. Yes. So finally, it will come to like this. Means one current is moving like this, another is again when negative cycle also comes, carrier is okay. This carrier current I2, you call it as a I by 2 means half of that. Both are in opposite directions, hence get cancelled here. But when positive cycle comes, D1, D2 conducts. When negative cycle of the carrier comes, D3 and D4. Means carrier simply it acts as a switching element. It acts as switching element. It switches. Okay. It open the gates. Okay. What is the role of this D1, D2? When this carrier, these diodes are acts as a switching diode. So this is the discussion without the message signal. Yeah. So this waveforms also I have shown here. Okay. Though in this way it will go, it will come here and both are opposite direction get cancelled. When negative cycle comes, you look at this current will be like this. It will go. Yeah. D4, D3. In this way, current will be again both are in opposite direction get cancelled. Yeah, when carrier is positive, D1, D2 conducts. When carrier is negative, D3, D4 conducts and gets opened, but output is 0. But output, both the cases, output is 0. But yeah. So now we will analyze when the message signal is positive. Like, so this is a waveform here, carrier, and this is a message signal. Yeah, when carrier is positive and negative, positive, negative, positive, negative. When it positive, with the absence of message signal, output is 0. But only thing is D1, D2 conducts. When negative cycle comes, D3 and D4 are get opened, means they are conducting, and D1 and D2 are get closed. Okay, means they are not conducting; they are switched off. Negative cycles. Yeah. With respect to the message signal, now we will see the analysis. Here, both carrier and message signals are positive. Means D1, D2 conducts, and message signal. This is also coupled to the secondary of the transformer, and same thing. It is also coupled to the. It means it's get connected to the. Means what the role of the carrier here? They makes the conducting, means these two diodes will be start conducting. Yes, and it will be appear, and the same output will be going to be appear output of the transformer. Means when positive cycle comes, when message signal is also positive, diode D1 conducting. When carrier is negative and this is positive, this is positive, and carrier negative. Look at this. This is the polarity here. Okay, this will be the path. Means when this still positive cycle, this comes here and polarity are reversed here. Okay, the polarity of the cycle will be reversed. Means this is the path here. Okay, in this case, when both are positive, this is the usual path. Yes, positive cycle comes, but when negative cycle comes, the carrier makes the diode D3 and D4. Means this, whatever the message signal, this part is there, same thing will be get appeared here. Appeared in means in the secondary, but the path is like this. It will be start moving in this. Means this will be the positive and this will be the negative. Hence output is also negative here. Negative. Which are the diode conduct? D3, D4. Similarly, next cycle. But again, when at this point there is a phase reversal here, okay? Because when negative cycle and positive, when positive cycle comes and negative cycle comes, again D3, D4 conducts. And again, when negative cycle comes, this is also negative. You look at this negative, negative, and in this case, D1 and D2 conducts. Yes, D3, D4 conducts. Means I can summarize here, when both are positive cycle, means message and carrier, D1, D2 conducts, output is also positive cycle. Message is positive, carrier is negative, D3, D4 conducts, automatically output is negative. When message is negative and carrier is positive, so we already observed that D1, D2 conducts and output is a negative. And both are negative. Message signal is also negative, carrier is also negative, D3, D4 conducts and output is a positive voltage. Okay, this we can clearly observe. Okay, negative, negative at this point, at point. Yes, okay. This will be the positive cycle, negative, negative. When positive comes, positive and negative, negative cycle comes. Yeah, in this way, diode ring modulator works. This will be the entire operation. Carrier signal, message signal, output of the, means when it is output of the transformer, and finally the entire secondary output will be looks like when we pass it through a filter. In this way, the ring modulator works.